Okay, let's do a little wrap it up. Show you how to do one of the last problems. Plus, we're going to talk just a little bit more about the conjugate. Just a little bit. It's much to see graphically. Huh? Here we go. We got a graph. A little 3 by 3. We got z is equal to 1 plus 2y. So while we do draw like a line from the origin up to it, that's not really there. We just use it as a tool to help you see it's a frickin' right triangle. But so we're going to be like 1 comma 2. So there it is. There's z right here. Now let's talk about its conjugate. And I don't see it a lot in your text. But typically the way you're going to write the conjugate, like if you're going to write c, is just put a little bar on top of it. It's saying it's the conjugate. So the conjugate would be 1 minus 2y. But look what happens. The conjugate is always symmetric about the x-axis, right? You're going to get the same x value, yet your y values are just going to be a little bit different. So maybe if I'm just even to write it as z is equal to a plus bi, and then our little like z bar, its conjugate, which is equal to a minus bi. Well, say a is, or say the z in blue is just right down here. Well, then I know that I just need to follow it on up and be like, well, it's symmetric about the axis. So it's always going to have the same way you think of it as an x value, but the y values will just be changed. Oops, I mean the imaginary values would just be changed. So it's always going to be symmetric about the real axis, or what we typically think of as the x-axis. Thought we talk. Okay, now here's something a little silly. And you're going to get questions asking you about the distance between 2 points. Now, they're going to put it up like this, and you're going to be like, how do they have it? How do they have it? Sorry, I'm just really kind of, they write it like this. S minus a squared plus, what is it, t minus b squared, and that's how you're going to find the distance. That's the distance formula, dude. That's the distance formula. Now let's just look and see how we're going to solve it. What I'm saying is, like, what if you have a vector z, and let's make it, I don't know, let's make it 2 plus 3i. And then, oops, why did I put a little bar on top of it? Start talking about it. And then we're going to talk about some other complex, and we'll call that w. Let's say it's 5 minus 2i. Well, you can just take this stuff and plug it all on in and go. We're basically saying that this is s plus ti, and this is equal to a plus bi, and then just replace things and go. But if we want to find the distance between z and w, we can use that formula. Just the distance formula, just have it just locked in, know that you're going to plug it in. But I'd rather do something a little bit different. I don't know. I think it'd just be easier to do it this way. Because the distance is just, it's just the absolute difference between the two. We're just saying just subtract them. Just freaking subtract them. Let's put that stuff in there. 2 minus 5, negative 3. 3 minus negative 2, that's 5. It doesn't matter. You could do it the other way. You could do w minus z, because we're about to take an absolute value of this thing. And then we put it inside, and we go, well, that's going to be negative 3 all squared plus 5 all squared. So that's going to be what? 9 plus 25, and that's going to be equal to the square root of 34. So one way to find that distance between two of these complex numbers is just find the difference. Find the difference and then do it. But you know what this is? Find the difference and then square all the stuff up. So it's all the same formula no matter how you do it. I did it this way, or we could have just looked at it and said that this is A, this is B, this is S, this is T, and then ran through and done our formula from what's up top. the distance is equal to some stuff squared plus some other crap squared. So it's S is 5, right? T is -2. And then we're going to subtract out. What are we going to subtract out? Oh, yeah, our A, which is 2, and our B, which is 3. So we're going to end up with the same freaking thing we just did above. But the signs are different, and we still get the square root of 34. Same answer, 2 different ways of going about it. So I like just finding the difference between the two and then finding it. Or maybe you're just going to want to memorize the formula, but you're going to have a few problems like this that are going to ask you to find the distance between two complex numbers. And our distances, we're always going to keep positive, so make sure you don't get any weird negatives in there. Okay, so we'll be back and we're going to start putting things into the trigonomic form of a complex number. We're going to get away from this just lead in, get you ready, and now we're going to start doing some trig in the next. So we'll have in 4.4, things are going to get wonky. They're going to look a little bit different, but man, it's not going to be bad at all. It's notation. If you get past the notation, you're going to find all we're doing is adding, subtracting, multiplying, and very rarely dividing. A little squaring. All right, see you in the next.